Welcome back everyone. In this lesson, we are going to begin setting up our player. Now, before we jump into coding our player, we first of all need to define their input actions, essentially which buttons on our keyboard perform which actions. So to move up, we need to click the W key, to move down the S key or the arrow keys, and to shoot, we need the left mouse button. These are things we need to define before starting our code. So I'm going to go up to Project Settings, and then at the top here, we are going to go over to the Input Map page. Now here, we want to go down to where it says Add New Action and basically give an action a name. For example, the Move Up action, hit Enter. And now what we need to do is assign keys or buttons to this Move Up action. So I'm going to click on the plus on the right hand side and press W. Now the W key is going to be selected in the list. We'll click OK, and there we go. Next, we can create the move down action, the move left action, and the move right action, and fill those in appropriately. So S for down, we then have A for left, and then we have D for right, like so. Now, the last action is going to be the shoot action, so we can then add that as well. But this time, if we click with our left mouse button, nothing appears. So let's go over to the mouse buttons list and find the left mouse button right there, okay? And that is done. So that is how we can set up all of our inputs like so. We can then close out of this window and begin setting up our actual player node itself. Now the player node is going to be of type character body 2D, which is a very handy node as that allows us to modify its velocity, it can detect collisions, it can bump up against things, and it's just overall probably the best node to use when creating a player. So I'm going to create a brand new character body 2D node right here. I'm going to rename it to be player, okay? Now at the moment, if I press W, you'll see that our player is in the middle of the lava, so I'm actually going to bring them down here on more stable ground, so we can begin working on them. Now, our player is going to need two things, a sprite and a collision shape. You can see we have a little warning sign next to our character body here. This is basically saying that for this thing to actually work, it needs a collider. But first of all, let's start with the sprite. So I'm going to right click on player, add child node, and search for sprite 2D. I'm going to rename this node to just be sprite so it's nice and simple. And then over in the right hand side where we have our texture property, I'm going to go ahead and drag in the sprite sheet. Now there's one issue, and that is the sprite node is using the entire sprite sheet to basically render the player. But we don't want that. We only want one little selection of this sheet. So how do we do that? Well, what we can do is go down to where we have region and then enable that. Now, if we click on the Edit Region button, this is going to allow us to search the sprite sheet and essentially just select a bit of the sprite sheet and have that render only, okay? So I'm going to go ahead and find a nice sprite for our player, okay? Since our player is going to be shooting arrows, I think I'll go with this arrow character right here. So I'm just going to select that node. Make sure it is properly aligned. Now, there's going to be one issue, and that is when you're trying to align the sprites, it's not really going to snap. Now, to make it snappy, we can go up to snap mode and set that to pixel snap. Now, when we move this grid around, it is going to snap to pixels, which is exactly what we want. And there we go. So now we can make sure everything's selected, close out of that, and now we have our player sprite in the world, which is great, okay? Now the next step is going to be adding in a collider, okay, because we need the player to be able to detect hits against obstacles as well as other enemies as well as projectiles. So I'm going to right click on player, add child node, and search for a collision shape 2D. Now, on the right hand side where we have the shape property, we can choose what sort of collider we want. Now I'm going to select capsule shape 2D just because this more closely resembles the sprite for the player we have here. And I think this is actually pretty good, the default settings it gives us. Now it's not exactly on the player, and the reason why is because our player sprite is going to be flipping left and right based on where we are looking. So if we are looking to the left, we're going to keep the player looking this way, but if we move our mouse over to the right, if we open up offset, we can toggle the flip H property, which is going to basically flip us to looking to the right, okay? So we kind of just want a rough estimate for our collider here. Okay, the next thing we're going to do is change the origin of our player's sprite. The reason why is because eventually when we get to moving our player around, we're going to get a nice little visual that is going to wobble the player's rotation left and right like this. But we don't want it to be from the center, we want it to be from the player's feet. That's just going to make it look like they have a bit of a walking animation. So to do this, I'm going to go to offset and I'm going to change the Y offset here to be something perhaps such as -12. Now you'll see that the origin or the pivot point for the sprite is down here at its feet, but our sprite is then too far up, so we need to move it down. So I'm going to go to its transform position and set the Y to be 12. Now it is back to being centered, but if I go ahead and rotate it now, you can see the player rotates from its feet, okay? And that's going to give us that walking animation. That's just a little quirk, a little thing that we're going to be doing. You don't have to do it, of course, but that's just going to make our game look a bit more juicy in that way with all these nice visual elements going on. Okay, now finally what we're going to do before we actually start coding our player is going to be adding in a muzzle. Now a muzzle is essentially going to be where we want to spawn the bullet from on our player, because we don't want to spawn the bullet from the middle of the player. That's going to look a bit strange. So if I go ahead and create a brand new node 2D and rename this to be muzzle, we can go ahead and position this somewhere closer to around their head, okay? So if I then move this up like so, I reckon around here is a good place to be spawning our projectiles from, okay? And there we go. So that is our player setup. Now we're going to do a number of things. First of all, we are going to select our player and convert them into a scene so that if we have multiple levels, we can easily duplicate them. So to do this, I'm simply going to drag my player node into the scenes folder and save it as player.tscn. Then what I'm going to do is open up the player scene by double clicking on it. And for the next lesson, we're going to go ahead and create a script for our player. So I'm going to select our player node, go down to the script property, and create a new script here. Make sure it's saved to my scripts folder as player.gd and click create. Now we're not going to edit the code just yet. Let's go back to our player scene right here. And one last thing we're going to do is with our player node selected, go up to the top right corner where we have the node panel. Make sure we have our player node selected like so, and then click on the groups tab. Now here we are going to create a group for the player. A group is essentially a tag we can assign, so when we detect collisions later on, we can easily know, has this bullet hit an enemy or has it hit a player? I'm going to click on plus and call this group player like so, and click OK. Now this player scene or this player node has the group of player assigned to it. So later on when the enemies are shooting their bullets, we're going to make it so that the enemy bullets are only going to be able to damage objects that have the player tag, okay? So there we go. That is all set up now. In the next lesson, we are going to go ahead and begin scripting. So let's jump over to the scripting window and I'll see you all then in the next lesson. Hey everyone, in this lesson we are going to begin setting up our player movement. Now to do this we're going to have a few variables and the movement is going to be probably a bit more complex than you could be expecting. We're not just going to be moving the player along a certain direction at a set speed, rather we are going to have both acceleration and braking just to make it feel that much more smoother, and in reality it makes it feel a lot more fun to play with. So we're going to create three variables here. We're going to create a variable called max speed of type float, and this is essentially going to be the maximum speed that this player can reach. Now I'm going to make this equal to 100 pixels per second, and also let's go ahead and add this export tag to the beginning so that inside of the editor, or the inspector I mean, when we have our player selected, we can modify the variable here. Now we also then want another export variable for acceleration. This is going to be the rate at which we go from standing still to moving at our max speed, and I'm going to set this to be 0.2. And then we have another export variable for braking, and this is going to be the rate at which we go from moving to standing still. Now this is also going to be another small value of 0.15. Now it's going to take us a bit longer to slow down, just to add that more realistic, I guess, movement and smoothing, but you can adjust these however you see fit. Now, next what we're going to do is we are going to go ahead and create a variable here called move input, which is going to be of type vector2. This is going to basically keep track of which buttons are currently being pressed along the X and Y axis. Okay, this is going to give us a movement input vector, which we can then use to adjust our player's velocity. Now, where the bulk of the movement, or where all of it is essentially going to take place, is inside of the physics process function. So let's go ahead and create the physics process function right here with that delta parameter. And this gets called every physics frame. Now, first of all, we need to capture our move input. So we need to basically detect what keys are being pressed. Now, we could go ahead and check one by one. Okay, is move left being pressed? Is move right being pressed? So on and so forth. Or we can use this handy function that Godot has for us, which is only going to result in one line of code. So I'm going to go move input equals input with a capital I dot get vector. And get vector, we give it a negative x, a positive x, a negative y, and a positive y, and that results in a vector2 with all of the directions taking into account to provide basically a direction for us. So for the negative x, this is going to be move left, and make sure that these actions are spelt the exact same way as they are in the project settings. For positive x, we got move right. For negative y, we have move up. And then for positive y, we got move down, okay? Just like that. So this right here is going to result in a vector that we can use for our movement, okay? So the next step is then going to be moving our character based on this. Now, I'm going to do this two ways. I'm going to do the very simple way, and then I'm going to implement acceleration and braking. So first of all, to actually get our player moving around, we then need to go velocity, which is a variable built into the character body 2D node. This basically determines how many pixels per second we move in and what direction. I'm going to go equals move input times the max speed, and in order for us to actually then move, we need to call the move and slide function. Okay, now if I go ahead and press play, we should see that our scene starts up, but our player is kind of off to the screen here, but as you can see, they are moving around. Now, to make this a bit better to look at, I'm going to go ahead and add in a camera to our game here. Now this camera, okay, if we go into 2D scene here, and create a brand new camera 2D. This camera is not going to be a child of the player node. The reason why is because later on we're going to add our own custom camera follow script, which is going to add some smoothing as well as camera shake. So for this camera, what we can do is basically select it, move it down here to focus on the player. But again, you can see this pink outline, it's pretty big. So what I'm going to do is shrink our camera down. So here where we have the zoom, I'm going to set this to be 2. So this basically doubles the size of a pixel on our screen. Now if I go ahead and run this, you'll see that we have the view that we are going to have, and I can move the player around like so. But again, you may notice that the play is a bit snappy. Now, you might want this for your game, but a lot of games you might want some nice smoothing to basically make it feel a bit nicer to control. Now, let's implement that. So to do this, what we're going to do is delete the line of code where we are setting our velocity, and instead what we're going to do is we are going to check to see if the move input, length is greater than 0. So basically, if the length, which is basically the length of that vector, is more than 0, essentially, if we are pressing any of the movement keys down, this is going to be true. Then we are going to basically lerp our velocity. We're going to interpolate it from whatever it is right now to the max speed. So here we're going to go velocity equals velocity.lerp, and the 2 is going to be the move input multiplied by max speed at a rate, or the weight of acceleration, okay? So essentially what we're doing here is we are making it so that whenever we hold down a movement key, we're going to smoothly transition to our max speed at a rate of acceleration. Then we can do the exact same thing for braking. So we're essentially just going to add an else statement here and then go velocity equals velocity.lerp. Now the 2 is going to basically be nothing, so vector 2.0, so we want to stand still at a rate of braking, okay? So with this little code here, we can go ahead and press play and have a look at how this movement differs. Now it may be a bit hard to see it on the video, but for me, it feels like my character is sort of taking their time to speed up, and when I let go of the key, you can see how they smoothly transition to standing still. Again, it's going to be hard to see on the video, and especially if you're not controlling it yourself, but if you're following along, hopefully you can feel the difference in the code here. Now, something else we want to do is make it so that our sprite is going to face whatever direction our mouse is. So at the moment, my mouse is on the left of the player, but if it goes over to the right, we want that character sprite to flip around. So let's do that. To begin, we need to create a new variable that is going to reference our player's sprite. So here I'm going to create an onReady variable, which gets initialized at the start of the game. I'm going to call it sprite of type sprite2d equals, and we need a reference to our sprite node, so I'm just going to drag that in. If we go over to our player, drag in that sprite here. So essentially when the game begins, our sprite node is going to be assigned to this sprite variable here. Now down inside of the process function, which gets called every frame, so process here, what we're going to do is essentially make it so that our sprite flips based on our mouse position. So an easy way of doing this is going sprite.fliph equals get global mouse position, which is basically the position of our mouse. And then we're going to go .x greater than global position .x. So essentially what we're doing here is checking a condition. Is our mouse's X position greater than our player's X position? If so, then we are going to flip the sprite. Otherwise, we are not going to flip the sprite. Now, if I save that and press play, you'll see that my mouse, when it's on the left, and then on the right, the player is going to change its facing direction, which is pretty good. Okay, so that is our player movement setup. Now, you may be getting a bunch of debugger errors, and the reason why is because our Sprite Atlas has some errors, okay? So let's go ahead and fix those. So back in our main scene, I'm going to select my tile map, go down to my tile set window here. Now in the tile set, we essentially want to click on these 3 little dots here and select remove tiles outside the texture. This will make it so it's not trying to generate tiles outside of the texture. Now if we save that and then press play again, we should see those debugging errors are now gone. So in the next lesson, we're going to work on actually setting up the ability for our player to begin shooting bullets. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson we are going to be setting up our bullets. Now this is essentially going to be the projectile that both our player and our enemies are going to be shooting out from them, okay? So what we're going to do is we're going to start off by creating a brand new Area 2D node here in our main scene. Now an Area 2D is essentially a node which has a collider, and all it does is essentially detect when things pass through it, okay? You have a static body, which is a solid object, and an area, which is a collider that has things pass through it, like I mentioned, okay, like a trigger. So what we're going to do is bring it down here. We're going to rename this one to be bullet. And we need to give it 3 things. First of all, we're going to give it a sprite 2D node, which we are going to rename to be sprite. We're then going to drag in the sprite sheet into the texture field, go down to region, enable region, and then click edit region, okay? And what we're going to do is essentially go in here and find a projectile we want to use. For example, we might want to use this arrow right here, okay? So I'm going to select the arrow here. There we go, and close out. Now with this arrow, we then want to give it a collider. So I'm going to right click on the bullet again, add child node, collision shape 2D. We're then going to go over to the right hand side and give it a rectangular shape. Okay, I'm just going to make it sure it fits the bounds of this arrow just like so. Okay, and there we go. Now, the next node we are going to create is going to be a timer node. So if I go ahead and create a timer node here, I'm going to rename it to be destroy timer. The reason why is because when we shoot things, we don't want them to keep going on forever if they don't hit anything, okay? We want to, after maybe 5 seconds, have it so that our projectile gets destroyed, okay? So over here in the inspector, I'm going to go ahead and set the wait time. We're just going to make it about 4 seconds perhaps, and then auto start we're going to enable as well. And that is pretty much all the nodes that we need for our bullet here. Now the next step is of course going to be creating a script. So on the main bullet area 2D, we're going to go down to the script, create a new script, make sure this is saved to our scripts folder, and call it bullet.gd. Okay, so inside of here, what we're going to do is essentially provide a few variables, and we want to then move this bullet along its given move direction every single frame, and also then detect when we are hitting something, okay? So inside of here, what we're going to do is start with our variables. Now, we're not going to fill in everything for this script in this lesson, more so just the bare bones to actually get it working. So I'm going to have a variable, an export variable called speed, of type float, and this is essentially just going to be how fast the bullet is moving, okay, each frame, or each second I mean. So I'm going to make this 200 pixels per second. Now we're also going to have another export variable for owner group, okay, and this is essentially going to be who owns this projectile, okay, is it the player, is it the enemy? And this is just so that we don't hit ourselves when shooting. We're then going to have an onReady variable for the destroy timer of type timer, import the destroy timer path like so. And then we are also going to have a variable called move direction or movedir of type vector2. And this is going to be determining the direction that we want the projectile to move along. Okay. So down then inside of the process function, inside of here, we are essentially just going to move along our move direction. So here we are going to go translate, which essentially moves us over time. And that translation offset is going to be our move direction times by speed times by delta. Okay, so we're going to be moving in the direction at a rate of speed per second. We then also have the code to run when we hit something. We're not going to be implementing that fully, but we will add in the function here. So if I select my bullet, and go over to the node panel, go to signals, you'll see we have the body entered signal. This gets called when the area 2D node enters another body, for example, a character body. I'm going to double click on that, go down, select my bullet, and click connect. Now we should have that function connect into our script right here. And this is essentially where we're going to check to see if we've hit something, and if so, we then want to essentially damage it. And then what we need to do is have another signal that gets run when the destroy timer is called, or when it times out. So I'm going to select my destroy timer, go to signals, and double click on the timeout signal, which gets called once the timer reaches 0. Select the bullet, click connect, and there we go. Now inside the destroy timer, what we're going to do is essentially just destroy the bullet. So we're going to go Q free. Now if we go ahead and run this, you should see that after 4 seconds, this arrow should disappear. And there we go. So after 4 seconds, that arrow has been used up and it is now destroyed. Now eventually once we get into pooling, node pooling, we're not going to be destroying anything, but rather we'll be toggling its visibility. But for now, we'll keep it like this. So that is our arrow bullet right there. I'm going to go ahead and save this as a scene by dragging it in like so. And then we can delete it from our main scene. Now, in the next lesson, we are going to be looking at setting it up so our player can begin actually shooting these bullets. So thanks for watching, and I'll see you all then. Welcome back everyone. In this lesson, we are going to be implementing player shooting. Now, we're going to be going about this a bit of a strange way. We're going to be implementing it in this lesson, but in future lessons, we are going to basically modify quite a large chunk of what we are writing here. The reason why is because in this lesson, we're going to make it so that when the player shoots, it is essentially going to create a new bullet, shoot it off, and then destroy it. Whereas later, when we implement pooling, that is where we are actually going to be reusing these bullets. So let's start by going over to our player script here, and we need to add in some new variables, okay? The first variable we're going to add is going to be an export variable called shoot rate, and this is essentially going to be a float, and we'll make it 0.1. This is essentially going to be the rate at which we can shoot, so 0.1 means we can shoot every 0.1 seconds or 10 bullets per second. Then we're going to create a variable for the last shoot time to keep track of the last time we shot a bullet. And then we also want to have a variable that references our muzzle. So on ready var for the muzzle, and this is just going to be equal to the muzzle node here. Okay. Now next what we're going to do is we are going to go down and we are going to go to the process function here. Now, inside of the process function, what we're going to do is basically check to see if the shoot action was pressed. Now, to do that, we can go if input with a capital I dot is action pressed, and then we can find the shoot action right here. Then we want to also check another condition, and that is if we actually can shoot, because we don't want to shoot every frame that we're pressing down the button. We only want to shoot on the frames if there is enough time passed between the last shoot time. So for this, we're then going to go if time.get Unix time from system, which is basically the amount of seconds that have elapsed. If this minus the last shoot time is greater than shoot rate, then that means enough time has passed and we can shoot. And I'm going to call the function underscore shoot, which we're going to go ahead and create right now. So the shoot function, which we're going to create, this is essentially going to create a bullet, position it on our muzzle, give it the direction it needs to move in, and then send it off. So first of all, what we're going to actually do is set the last shoot time. So last shoot time equals the current time, which is time dot get Unix time from system. So we are basically updating that. Then we need to spawn in a bullet. And to do this, I'm going to create a variable here, just one that is temporary. So I'm going to leave a bunch of gaps here. And this is just going to be called bullet scene of type packed scene equals preload. And we just want to preload our bullet scene like so. Then down here inside of the shoot function, we can go ahead and spawn in our bullet. So I'm going to create a variable called bullet equals bullet scene dot instantiate. Now the instantiate function basically instantiates a new copy of that scene. Then what we need to do is essentially add it to the node tree, because right now this instantiated bullet exists inside of our memory somewhere. So we need to basically latch it on to our tree. So for this, we're going to go get tree.root.add child bullet, okay? So here essentially we are instantiating the bullet and then we are adding it to our node tree, okay, or our scene tree. So let's go ahead and run this and see if it works. So if I go ahead and press left arrow, you can see that nothing is really happening, and that is because even though the bullets are spawning, they are not being positioned on top of our player. So to do that, what we need to do is then go down here and go bullet.global position equals muzzle.global position, okay? And if I run that now, we should see that the bullet is being instantiated on top of the player, which is great, okay? But second of all, they're not moving. They're kind of standing still. So we need to actually specify a move direction for the bullet. And this move direction is basically just going to be the direction from the muzzle to the mouse position. So what I'm going to do is I'm going to create a variable called mouse pos right here. Mouse pos equals get global mouse position. Then I'm going to create another variable called mouse direction equals muzzle dot global position dot direction to mouse pos. So here we are essentially getting the muzzle's position and then calculating the direction from that to our mouse position, and that direction vector is what we are going to set as our bullet's move direction. So here we'll then go bullet dot move direction equals mouse direction. Now if I save that and press play, we should see that when I shoot, that bullet is now flying off. Okay, so we are now shooting our bullets, which is great. I can hold it down, but there's also one thing that's happening, and it's a bit strange, and that is our bullet is kind of just, not rotating, okay? It's kind of just sitting flat. So we want to make it so that our bullet changes its rotation based on its move direction. So to do that, what we're going to do is go over into our bullet script, and we're going to go to the process function. And here what we're going to do is we are essentially just going to go rotation equals move direction dot angle, okay? And this little line of code is going to make it so that our rotation is equal to the angle of our move direction. So if I go ahead and run this, you should see that our bullets are now pointing in the direction that we are shooting, which is great, okay? So that is all working nicely here. Okay, so let's have a look at that shoot function once more. So essentially at the start, we are setting our last shoot time to be now. We are then instantiating a new bullet, so basically spawning in a new bullet. We are then adding it to our root of our node tree, so it exists in our scene. Then we are setting its position to be our muzzle's position. We are then getting our mouse position, and then calculating the direction from the muzzle to our mouse position, and assigning that to the bullet's move direction, okay? So that is the basics of shooting. Later on then, when we add an audio, we'll make sure we have a little sound effect play here as well. But for now, we'll leave it like that. So in the next lesson, we are going to be looking at node pooling, okay, object pooling, and this essentially allows us to reuse objects that have been destroyed without having to spawn them in again, because spawning in an object can take some processing power, as we have to basically run the code to create a new slot in memory, assign all the values to it, whereas if that memory slot is already there, it's going to be very quick to just grab it instead of creating something new. So thanks for watching, and I'll see you all then. Hey everyone, in this lesson we are going to be looking at setting up a node pool. Now what is a node pool? Well, the concept of pooling basically works like this. In video games such as what we are creating here, where there are a lot of bullets and a lot of enemies on screen at once, we have to go through the process of spawning them in. Then when the bullets hit something or when an enemy is destroyed, we have to destroy or delete that node. Now the process of instantiating or spawning in a new node is a process where we basically have to find new space inside of memory and initialize all those values, and if we are doing that many times per second, that can impact performance. So what we do instead is use pooling. Now pooling essentially, it creates, for example, let's just say we have our player and they are shooting their bullets. Well, when the player shoots a bullet, what we do is we check to see, okay, do we have any cached bullets? Do we have any bullets that are no longer being used? Well, no, because the game just started, so we create some new bullets. Then instead of destroying that node when it is, done, when we're done with using it, instead what we do is we just toggle its visibility to be off. We basically turn that node off. And that node then waits until we need another bullet. Then what we do is, instead of spawning in a new bullet, we get that disabled node and we reactivate it. Okay, we are basically recycling nodes here so that we are not going through the process of instantiating new nodes every single time we need one. So we're going to do this with a node pool script. So I'm going to go ahead on my player here. I'm going to go ahead and create a brand new node. Now this isn't going to be node 2D, but rather just node, as basic as it can possibly get. And I'm going to rename this to be our player bullet pool. Okay. And then over here inside the script, we're going to create a brand new one here. Save that to our scripts folder. Now this is going to be what's known as a generic node pool. Essentially, this node pool is not going to be specifically for bullets or for enemies, but rather for nodes in general, okay? We can use this script for anything. You can reuse it wherever you wish. Because of that, I'm just going to call it node pool, okay? There we go. Now, inside of the node pool script, we are going to have two variables. The first one is going to be an export variable for the node scene. So this is essentially going to be the scene that we want to instantiate and use in this pool. And the second variable is going to be called cached nodes. And this is going to be of type array, which is going to contain our node 2Ds. And this array right here, which is basically a collection of elements, is going to store every single bullet or every single enemy that we spawn with this script. And then when we want to get a new one, we will search through cache nodes. If there aren't any disabled or deactivated nodes inside that list, we will activate it and return it. So now we also need two functions. We are going to have a function called create new. So create new right here, and this is going to return a node 2D. Essentially what this function does is it creates a new node, adds it to the tree, and then returns it. This is going to be used by our other function. So in here I'm going to create a variable called node. This is going to basically be equal to node scene.instantiate, because yes, we still need to instantiate nodes, but we're just going to be doing it a lot less. Then what we're going to do is we are going to add it to the cached nodes array. So we can go cached nodes.append node like so. Then we need to add it to our tree, okay, our scene tree here. So what we're going to do is we're going to go get tree dot get root dot add child, and we're going to add the node as a child to that. Okay, and then finally we're going to return that node. Now the main function, spawn, is going to be what we are actually going to be calling when we want a new node. So here we're going to create the function called spawn, and this is going to return a node 2D as well. And in here we essentially want to create a for loop that goes through each node inside of this array here. So we'll go for node in cached nodes, and we basically want to check to see if a node is invisible. So if node dot visible equals false, then that means that node has been deactivated. So what we're going to do is we're going to re-enable its visibility. So node.visible equals true, and then return it. Now, if there is no nodes in this list, or if every node is still being used, then we are just going to go ahead and return create new. Okay, so we're going to create a new node and just return that instead. And that is everything we need for this script right here. Now, how do we go about actually plugging it in to our player? Well, what we're going to do is we're going to go back to our player script, and you see here where we have the bullet scene variable. Instead of that, we're going to delete it and replace it with an onReady variable called bullet pool. And this is going to be equal to that player bullet pool we created just before. Now, down inside of the shoot function, instead of calling bullet scene.instantiate, we're going to call bullet pool.spawn, okay? And that is everything we need to do here. Now finally, we just need to select our player bullet pool here, go to the node scene, and drag in the bullet. And that is it. Now our player is utilizing the pool instead of instantiating a new node every time it needs it. But before we press play, we need to do one more thing, and that is going over to our bullet script, because remember, when the destroy timer times out, it is calling the queue_free function. So what we're going to do here is, instead of destroying the node, we simply want to set visible equal to false. Now, if I were to press play and run this, we'd be able to shoot our bullets fine, but every time we reuse a bullet, that bullet will never go away. That bullet will always be visible. The reason why is because, remember, this timer right here, once that gets timed out, this gets called, and then, well, nothing happens. We never disable the bullet ever again. So what we need to do is basically be notified whenever the bullet changes visibility. So I'm going to open up my bullet scene here. I'm going to select the bullet, go over to node, signals, and down at the bottom you see we have this visibility changed signal. This essentially gets called whenever the visibility gets toggled. So I'm going to connect that to my bullet script here, and inside on visibility changed, we are simply going to check to see if we are now visible. So if visible equals true, and destroy timer. The reason why is because this will be called at the start of the game when the destroy timer is not yet set. So we need to make sure that destroy timer exists. Then we're going to go destroy timer.start. So essentially restarting the destroy timer. Okay. And there we go. So now if I go ahead and run this, we should see that just like before, our player is shooting our arrows, but we can't really tell anything's happening. Oh, and you see we got an error when it tried to reuse a bullet. It is actually returning null, so we need to actually go ahead and check to see what is going on here. Over in our node pool, here we are just returning, whereas we actually got to return the node, okay? So make sure you're returning the node, not returning just nothing, okay? Otherwise, that's going to result in an error. So if I press play again and keep shooting, you can see that we are shooting our arrows and it is working fine. But now let's actually see this working. So what I'm going to do is I'm going to press play again, and over inside of the scene here, I'm going to click on remote. Now this is going to show me every node that is inside our current game scene. You can see when I create new bullets, those get added to the list there. So I'm going to keep firing my bullets for a bit. And you can see that list is growing, but after a while, it is going to stop growing, okay? So if I keep on firing for a bit, I'm then going to go in this list, scroll down to the bottom, and you can see that we created a total of 37 or 38 different bullets. But when I'm firing, you can see that we're not creating any more, but rather we are reusing them. You can see the visibility toggles on for when we use it, and when I stop using them, you see their visibility is going to toggle off. Okay, so no matter how many bullets I shoot, we have only ever spawned in or only ever instantiated 38 of them, no more and no less. Okay, whereas if we were spamming it like this, and we have maybe 20 other enemies doing the same, we don't want to be calling the instantiate function hundreds of times per second, as that is going to lag out our game. So caching these bullets is going to be the best way of solving lag in a game like this. Oh yeah, and over in the player script, one more thing, down inside the shoot function, we want to delete this line of code here because we are no longer needing to add the bullet to the scene. It's already added to the scene, so we can just delete that and everything is going to run fine.